Before moving on to some experiments involving light, it's important to cover some of the basic quantities of light that we're going to be working with. Now in this video, we're going to be talking about power and photon energy. You're probably already very familiar with power, and power is energy per unit time, so it's measured in joules per second, or watts. Now, let's create an example to explain this concept. So say you have a packet of food that is to be cooked in the microwave. And the way a microwave works is it transfers energy to the food using light. Particularly, this is light in the microwave region of around 2.45 gigahertz. That's the frequency of the light we're using here. So let's say we were to cook the food for 2 minutes in a 1000 watt microwave. And let's assume that the microwave is 100% efficient. So all that 1000 watts of power is being transferred into the food you're cooking. Now, the question is first, how much energy total will be transferred to the food in that 2 minutes at 1000 watts? Well, we know that 1000 watts means 1000 joules per second being transferred. In other words, we have 120 seconds for 2 minutes multiplied by 1000 joules per second, which gives us 120,000 joules total energy. The next question we might be interested in is how much energy a single photon of the microwave light contains. Now, to find this, we actually need to introduce a new equation, the equation for the energy of a photon. And this energy is given by E equals hf. E is the photon energy, h is Planck's constant, and f is the frequency. So in our particular case, we know f to be 2.45 gigahertz. Planck's constant is something you have on your formula sheet, and we can substitute those terms into the equation to get an energy per photon of 1.62 times 10 to the negative 24 joules. Finally, another interesting question is, how many photons total does the microwave have to give out in order to transfer the total amount of energy to the food? Well, we know the energy per photon now, and we also know how much energy is transferred total. We calculated that at the start of the problem. So all we have to do to calculate the total number of photons is take the total energy and divide it by the energy per photon. And when you do that, you get 7.41 times 10 to the 28 photons, which is a lot.